When the Voyager spacecraft passed by Jupiter, they discovered that Jupiter had a small ring around it. Since early in the days of telescopes, the 1600s, they knew that Saturn had rings, certainly by the mid-1600s, and those rings are easy to see with small telescopes. But Jupiter having a ring was a shock. Then astronomers discovered as Uranus passed in front of a star, occulted star, that the star dimmed out and brightened back before and after the planet went by, indicating that there were rings around Uranus also. Well, that meant 3 of the gas giants had rings around them. And so, sure enough, when the Voyager 2 spacecraft got to Uranus, it found rings. Well, just before the Voyager 2 got to Uranus, astronomers got to wondering if 3 of the 4 gas giants had rings, could the 4th one also have rings? Because that would seem to make sense. If 3 out of the 4, 75% of them have rings, what keeps the other one from not having rings? The reason they had not seen rings around Jupiter and Uranus were that they were too dim. So maybe Saturn was the weird one having rings, not the others having weird rings that are dim. Maybe Saturn was weird by having bright rings. And so in 1984, astronomers Boucher, Hafner, and Manfred were at the Silla Observatory studying an occultation of a star by Neptune. And so what was going to happen is Neptune was going to pass right in front of a little star. And so if there were rings around Neptune, then the star would dim out just before Neptune got there, reappear. Neptune would go in front, dim it out, and then it would dim out, it'd reappear, then dim out and reappear again as the other half of the ring goes by. So as they were studying, they found out that sure enough, the star dimmed out and brightened up on one side of Neptune a couple of times, indicating rings. But they did not observe the same thing on the other side. And so that indicated something weird was going on here. Some kind of like partial rings or something. And so this was all in preparation to the Voyager 2 arriving in 89, because as I said earlier, you've got to plan way in advance what you're going to be looking at. And so you needed to know whether there were going to be rings there to begin with and where to look. And so this just further confused the whole issue. And so what happened was when the Voyager 2 did arrive, it found rings, and sure enough, as expected, the rings are thicker on one side of the planet than on the other side of the planet. In astronomy, we refer to these as ring arcs. So it's an arc of a ring rather than a complete ring, because on the other side it's much thinner. And so the question is, why are the rings lopsided like this? And so what's going on? There's several different ideas. One idea was maybe it was a moon that recently fell inside the Roche limit and broke apart and had not yet spread out. The other possibility is that there might be a complex system here of a shepherd moon keeping the rings together, but possibly another moon in the same orbit as the rings. So the rings tend to be 60 degrees in front or behind of that Lagrange moon. So right now we don't really know. As the Voyager 2 flew by, as I said, we really didn't know what to look for exactly. We had to program the observations way in advance. This was going to be a very fast flyby, so they're not going to be there for very long, and it was going to be very dim, so very long time exposure, so very few photos. And so all the images had to be planned out in advance, and there really weren't enough opportunities to completely survey in great depth everything. So we honestly don't know this is one speculation as to what's happening, but we're not really sure. We're still not sure about the whole ring arc thing. Okay. So the rings do have names. The several different ring arcs, Gaul, Arago, Leverrier, Lassell, Adams, all got rings named after them. If you remember, a lot of these were names that were in this whole story of searching for the planet. And I think maybe some others maybe should have gotten credit in there as well. So, but those are the ring systems right there. The moons of Neptune, there were only 2 moons that were known prior to the Voyager 2 spacecraft. So only 2 were known, and the Voyager 2 discovered several right away, and then a few more have been discovered by the Hubble telescope after that. All the moons are named in mythology after water gods mythology. We have so far discovered 14 moons. 7 of them are considered regular satellites, meaning they're orbiting close to the equator. They're orbiting in the direction that the planet rotates. Everything's just fine. 7 of them are called irregular satellites that orbit somewhat differently. Triton is actually an irregular satellite, even though it is by far the biggest thing here. In fact, it makes up almost the entire moon system. Triton is a very large moon. Triton is almost as big as the other giant moons in the solar system, Titan and Ganymede. So it is huge. It is close to the size of Pluto in size. It orbits backwards. It orbits in retrograde motion, so it goes around not in the direction the planet's rotating, but the other direction. That means the tidal forces there are pulling on it, slowing it down, and making it gradually spiral towards Neptune. Now, this is the wrong orbit for a moon, so that suggests that Triton is perhaps a captured object. Nereid is the other moon that was known prior to the discovery of by Voyager 2. Until Voyager 2, the only 2 moons that were known were Triton, which was discovered shortly after the planet itself was discovered, and then Nereid. Nereid is a very irregular looking sort of thing. This is the only picture we have of Nereid right here. It's named after a sea nymph. Nereid, that picture was taken by Voyager 2. It's the only picture we have of the moon. It is in a exceedingly elliptical orbit that orbits with a period of about 1 Earth year. Now, that's huge for the orbit here, and it was actually near its farthest distance from Neptune when Voyager 2 went by, so just that one picture is all that we have of it, so we don't really know much about it. Our best guess is that Nereid is probably a comet that got close to Neptune and got caught in its orbit, or something similar to that. Of the other moons here, these are a handful of moons that were discovered purely by accident, as pictures will be taken of other things in the same field of view. 5 of them discovered by Voyager 2. And there's a variety of these little moons, all named after mythology, water gods, water nymphs, or something like that. 5 more moons were discovered using the Hubble telescope between 2002 and 2003. By far, the biggest of the moons is Triton. And when you look at Triton, you see something here that's, well, it's like a world. This is like Pluto. In fact, for many years, because Pluto's orbit is so elliptical and crosses the orbit of Neptune, they used to suspect maybe Pluto was a moon that got ejected from Neptune. More likely, Pluto is a icy planetesimal that never got caught by Neptune, and probably Triton is actually an icy planetesimal like Pluto that did get caught into orbit. At least that's one possibility. And so you actually notice that there's a lot of similarities between Triton and Pluto. One interesting thing is that there's this terrain here they generically call the cantaloupe terrain, which is believed to be wrinkling and deformation of the surface, even possibly resurfacing due to frozen ices under the surface coming out into the surface. Again, cryovolcanism. This cryovolcanism here is indicative of something that you normally see in the outer solar system.